Thanks, everyone, for coming. As she said, I'm Andrea Burbank. I'm a data scientist at Pinterest. If you're not familiar with Pinterest, it is a visual discovery platform to find new ideas and try them out in real life. If you haven't tried it, you should. The people in the last talk had free Lego giveaways. I'm giving out free membership to Pinterest to all of you. Try it out after my talk. You can go to pinterest.com. If you aren't familiar with it, as an example, my sister called me yesterday. She threw a birthday party for my 6-year-old nephew. They filled water balloons with water and put tiny dinosaurs inside, froze them, took them out, and now they had dinosaur eggs that they got to crack open, and the 6-year-old thought it was amazing. So this is the sort of thing you can find on Pinterest. As for me, I joined Pinterest in 2012. We were about 50 people then. We're about 800 people now. So during that time, I built a lot of data infrastructure, did a lot of data analysis, built our A/B testing framework, and now I'm doing sort of ranking and relevance kind of stuff. So I've touched lots of pieces of the data stack as well as doing software, and that is why I want to talk to you today about software and data and how they depend on each other. So, also, I have a tendency to talk too fast. I'm going to try to speak slowly, but if at any point I speed up, feel free to raise your hand, and I will try to slow back down. It's not because I'm nervous, it's just because I talk really fast. OK, the theme of this talk is turning data into gold. And I actually object a little bit to this theme, because when you think of turning something into gold, you're basically digging something out of the ground that already exists, you're polishing it up and turning it into something valuable. But the thing with data is it doesn't already exist. Something creates the data. It is not raw material. And if you think about what creates the data, it's your software. It is the thing that you are running every day that's going to create the data, and you need to put as much thought into the process of creating the data as into turning that data into so-called gold. The other thing that bugs me is people say, oh, you know, I don't care about that big data stuff, or, well, I'm just a data scientist. I don't know anything about software. And I think the key to success is to marry those two together. No one can be just a software person or just a data person. To be successful, you have to understand a little bit of both. And so with that, data as software is data. The idea is better software for better data for better software. Where am I going with that? This is sort of what I'm going to talk about. It's a journey that Pinterest went through. So we went from having no logging at all to logging but no insights, incorrect data due to stuff we can't control, incorrect data due to stuff we could have controlled but didn't understand, messy data, correlation and causation with data, and how software can make data easier. Who is coming to Pinterest? This is the most basic thing you might want to know. Who's coming to my service? How many people are there? Perhaps how many billions does that make me worth? Etc. But if you think about the way a service works, it looks something like this. So we have a varnish caching layer that caches our most common requests and then passes through requests that don't hit the cache to our NG API and NG app servers. They talk to each other. They pass back data to the user. This is great. But when I say data in this context, they're just readings from something like a MySQL database. And in practice, it might not always be a MySQL database. It could be HBase or whatever else. But they're reading data that's persistent. That's what we need to run the service. So we have a database of users. We have a database of pins. Because from the very first day Pinterest existed, when you come to Pinterest, we have to know who you are and what pins you have. But what we don't have is any way to tell any more than that. So when I joined Pinterest in spring of 2012, we were experiencing exponential growth in our user base. And the way we knew that was that we had this database of users that showed us the number of registering users is taking off. But what we wanted to know was why. And if you look in our database, we have this database that's serving our service. We know a lot of things about the users. We know their first name. We know their last name. We know their email address. We know their gender. We know when they signed up. We know whether they want us to email them every day or once a week or once a month. But what we don't know is where they came from. Were they referred by Google? Were they referred by Facebook? Were they referred by the New York Times? Did they come to us from our homepage? Did they land on a pin that they found exciting? Did they land on a friend's page and join Pinterest? We just had no idea what was actually driving these users to sign up. And so we started to hypothesize, why are we so popular right now? Is it because we're invite-only, and so people think we're exclusive and more desirable? Is it because we're invite-only, and so it's all the same bunch of people who are all here reinforcing each other? Is it because we spread through word of mouth through a small community? Is it because Facebook is sending us a lot of traffic? Is it because of all these news articles I keep seeing about Pinterest? We had no clue. And so we did what anyone would want to do if they wanted to track something like daily active users. This is from Wikipedia. I won't read you the whole thing, but basically, if you ever want to become a very large company, which Pinterest has from the start, you have to have some idea of who's visiting you, because that's how people like advertisers want to actually buy eyeballs. And so you need to know this many people visited today and did something substantial. But if you look again at our architecture, nothing here tells us any of these things. We can tell you how many pins were created today, or how many users signed up today, because those are the persistent things we need to run our service. But we can't tell you anything more. And so we added a layer of Kafka. And for those who aren't familiar with Kafka, it's just a logging service. Through Kafka, we could write down what requests we were getting. This sounds super simple, but actually knowing what requests are coming into your service, how long it takes you to serve them, what you're returning, is super valuable. Now you know, gee, it looks awfully slow in this place, or it looks like we're returning a lot of 404s, why is that? Or things like that. But in addition, it means you can start to count who's coming. So the raw request log looks something like this. For every user, it has a for every request, it says what user made that request, what time that request was, what path it hit, what status it returned, and a whole bunch more things I'm not showing here. And so from that, we said, hooray, we can finally count who is coming. A DAU is a user who hits our service with a request. Awesome, my talk is over. Well, it's not that simple. So if you think about how email works, usually when you send someone an email, you want to know whether they opened it. And not just did they click and go to Pinterest, but did they even bother clicking on the subject line and saying, hey, this looks like interesting content. To achieve that, we embed a tracking pixel in the email, as most people do, that fires a little request off to Pinterest and says, I opened this email, and we know when it was opened and so on. And so if you look at our raw request log, it's not just those requests for a pin and a repin and visiting a user profile, but there's this little request on the bottom for the tracking GIF. Well, that's not a real user. That's somebody who opened their email on their phone or on their laptop. They didn't visit Pinterest at all. They just got an email from us. And so now we revise our definition of DAU to users with only a subset of certain requests. So that's great. Now we actually do know who's coming. We can count them. And we can write a query to do so. So we say, OK, you are a DAU if you are in the request log, and your path is not the tracking GIF, and it's on this day. Hooray. And so we make a graph that looks like this, and we can actually see how many people are visiting Pinterest each day. And that's really great, because we can see, oops, we kind of broke the service on those 2 days. We can say, hurrah, it looks like overall we're growing. But we might have more questions. Who are those users? Is it the same users every day? Or new users trying us out for the first time? Do people come back often? And so we come up with weekly active users. Well, that's fine. We can just query our request log again and say, in the last week, did this user visit on a path that's not the tracking GIF? These people are weekly active users. For monthly active users, that's fine. Did these people visit in the last 28 days and visit a path that's not the tracking GIF? And for yearly active users, did they visit in the last 365 days on a request that's not the tracking GIF? Well, this is starting to sound kind of expensive. If I'm logging every single request and going back over a whole year of it every time I want to do this, things are not going to go well for me. And so instead, we create derived tables. Again, this is super obvious, but tremendously valuable. And this is where software engineering helps you create the data you need. So instead of just counting the people who show up every day, we can write a partition to a table in S3 that says, on this day, this user was a DAU. And it looks like this. So on this day, this user had action type 0, which I've arbitrarily decided is DAU. They had 135 requests. This person had 200 requests. This person had 3 requests. And so to go back to our questions, who are the users? Is it the same users every day? Now we can find that out. We can write a new table of XD7 users, people who visit each week. We aggregate from our lovely unique actions table, so there's no parsing through these requests and trying to do it. It's just 1 row per user, runs in 3 minutes. I have this lovely table of weekly actives. I have a table of monthly actives. And now I can see how often users are coming to Pinterest. This sounds really dumb, but if you imagine being a company where your service has fallen over most days for the last 6 months and you've mostly just been working to make sure that people can come to Pinterest, having actual data that says, these are our users, this is how often they're coming back, is super useful. And so here's some data where I've erased some axes and so on. But we could see a lot of people were actually coming to Pinterest every day. A lot of people were coming only once that week. We wanted to know what happens the following week. And now we can look at that too, because we have these derived tables, and we can run a quick query and say, well, people who come every day this week tend to come every day next week. People who only came once this week, those are the people that we might not be losing. Those are the people who might not understand Pinterest. And that's an intuitive idea, but having the actual data in front of you lets you then target those people, figure out what's different about their behavior, and do things to help them understand Pinterest and stick around more. Here's another view of the same thing in case you like this view better. But basically, you can see the same trends, where people who visit, there's sort of a magic tilting point, where you can see if people are visiting less than maybe 3-ish days a week, they tend to move next week toward less. If they're visiting more than that, they tend to be even stickier next week. So people who visit 6 days a week probably will come back every day next week. Maybe they just were sick one day. And so on. We can ask other questions. So I wrote this query for this talk, but I just wanted to see if people came back 1 week a year ago, how many weeks did they probably come back this year? And most of them come back every week. And so we can see that, yes, the most common is they came every week. The second most common is they came every week except 1. The third most common is they came every week except 2. This is crazy, and this is stuff we can't figure out without this request logging. So what did we learn for Pinterest? We can actually count our users, and Pinterest is incredibly sticky. What did we learn about data as software? If you log requests, you can get a lot out of it, but you have to know which requests count. You probably want to create derived tables so you're not reparsing your logs over and over again. And having things like weekly and monthly aggregates can make your life a lot easier for understanding things like how people churn in and out of the service. Because it's not that every day I wake up and brush my teeth and say, gee, should I use Pinterest today? It's that I've built a habit out of it and I come back over the period of weeks or months. Counting is hard, but now we can count. We've completed part 1. Part 2. I mentioned one reason for counting, which is that eventually if you want to sell ads, you need to know how many people are coming. There are other reasons, like maybe I want to try a new feature and see how it worked. And so one reason we want to count is to know how we're doing. So here's our graph of daily active users. We talked about how we could find these outages. We talked about how we could see the growth. Let's apply that to a real situation. Fall of 2012. We had just launched Pinterest to be able to sign up with an email address. So instead of having to sign up through Facebook, you could just go to Pinterest.com, enter your email address, which you all are going to do after this presentation. It's going to be great, and join the network. In addition, we just released our first iOS and Android apps. So instead of only going to your computer and finding Pinterest, now we're on these lovely pocket computers. Well, and so we wanted to see what outcome that would have on our metrics. And so we could see that when we did these things, signups completely went through the roof. This is awesome. All of our hard work is paying off. We can see that not only is there a bump when we launched what we call open signup, but there's a second bump when we launch our mobile apps. We are getting the users that we're hoping to get. Hooray. But we started to wonder what was going on, and I hope it shows up there. We especially wondered what was going on when a few months later, that jump in signups went away. And we said, well, we still have open signup and we still have iOS and Android apps. What's going on? And so we took a closer look at our data. And we looked at the people signing up. And we had Candy21387 at hotmail.com, and Deborah2943 at hotmail.com, and Judancy9146 at hotmail.com. And I bet you could name about 300 other users that also signed up. And similarly, later on, we had Npzukufatutu at Yahoo and Kafka at Yahoo, and all these email addresses that probably no one you know has anything like that. And so yes, what we were measuring was spam. We had no idea what was going on with our business because of all these extra people who aren't actually people who were obscuring our metrics. The thing with spam filtering is that it's adversarial. What I mean by that is that every time you come up with a pattern that you identify what the spammers are doing, they're going to adjust their tactics to not be caught anymore. And then you come up with a new rule, they adjust their tactics, and you're constantly fighting with each other. Except, the nice thing about doing it for your internal metrics is it doesn't have to be adversarial anymore. You don't have to block their behavior. You don't have to let on at all that you know they're a spammer. You can just say, it's lovely that you're doing what you're doing. We are not going to count you when we're trying to figure out how our business is doing. And so you can take the adversarial part out of the equation and actually understand your business again. And that's what we did. So here's some examples of some of the people we could catch. So these are a number of users in our database who have this lovely quote, "I was born botanical with the soul of an animal." Now, if you sign up for Pinterest and that's your description, that seems perfectly plausible. People like to put quotes in their descriptions of themselves. But if you look at their email addresses, again, we see this common pattern where it's a capitalized first name and a capitalized last name and then some letters and then yahoo.com. These people are spammers, and we can tell they're spammers because they're so similar to each other. Here's another example. These are people whose username is a common female name, followed by a digit, followed by 2 letters, or sometimes followed by 2 letters and then followed by a digit. And so you get the idea here. Like, we're not computers. We're very, very good at pattern recognition. We say, these people look like scum. We need to get them out. Sometimes it's a little bit different. So this is a user from China who has 50 boards but no pins. Every single one of these boards is a phone number for an escort service in a different city in China. There are hundreds of users like this so that their profiles will show up on Google. And when you see their little snippet, it will tell you how to call this escort service. So these are the sorts of people we're fighting with. The good thing is, we can do that. So we have this database of users, and we can write rules that find these people. People who have the same description as each other. People who meet these certain regular expressions in their email address. People who sign up with the same name. We can do the same for pins. People who sign up with the same weight loss, or so who create the same weight loss image. People who only pin from a single domain. People who pin the same link over and over. People who pin the same image as someone else who's spammy. People who created boards called "I'm the boss" and "make lots of money." We had a whole bunch of those for a while. People who delete and create boards within a second. People who sign up from the same IP as people who only signed up via email. I could keep going forever. Clearly, there's a lot of these. But the point is, for every one, you can just write a simple rule. And it looks something like this. Insert overwrite table, pinalytics.possible spammers data. Great, that's just a spot in S3. This is for all the people whose first name is Gujahafata and whose last name is Fahajitar. This sounds ridiculous, right? I can't even say these words. But there were, I don't know, 200,000 of these people who were messing up our data. And so all we do is say, great, this is dumb, but I'm just writing a partition. We're solving our data problem with software engineering. And so we write all of our rules, and we populate this table of possible spammers data. And it's just a workflow. This is a screenshot from our workflow tool. It runs every night. We figure out who's violating our rules. We decide not to count them in our metrics. We integrate that with the real-time spam service, which actually is adversarial and does have to block these people's activity and so on. I won't talk about that today, but I'm happy to answer questions about it, to create a new table called spam users. And now we can filter spam. And so we take our spam users table, we take our XD7 users and our XD28 users table, which count weekly actives and monthly actives, and we can spam filter them. So we have spam adjusted versions of those tables. We actually know what's going on. And we create spam filtered versions of a lot of other tables. And now finally we can have a clue about our business. So here's a workflow for that. Again, it's a workflow. It has dependencies, it has jobs, they run every night, simple software engineering problem. and we're good. And so instead of this graph of signups, we have this graph. Look, we actually did increase signups a lot with our launches. We just also opened up the doors for spam. And so once we leave out that little dotted line of spam, now we can actually measure how we're doing. We can say, hey, these 2 weeks of effort we put in provided this return on investment. We can tell whether opening up our service in other countries is a good idea, et cetera. Data as software. Aggregate your data, build workflows. It's software engineering to solve these data problems. We can finally count who's coming again and have a clue what's going on. Let's do this again. Daily active iPhone users. So fall of 2013, we saw a step change in the growth rate of people visiting on iPhone. Hooray! We wanted to know why and said, well, it's likely because we were featured in the App Store. And indeed, we'd been featured in the App Store by Apple for launching on iOS 7. But how much of that jump would that explain? We started to dig in further. What else might have happened? So the mobile PM wrote an email to the entire company. Do you have an iOS device? Check out Featured in the App Store. We launched 3.0 of the iOS Pinterest app today, which represents a huge amount of work from the mobile team. An inspired combination of iOS 7's and Pinterest visual language, the interaction model has been carefully designed. Transitions, gestures, and information architecture were painstakingly thought through. That doesn't sound like we were just featured in the App Store. That sounds like we rebuilt a whole bunch of stuff. So what's special about iOS 7? Well, if you look it up, what changed in iOS 7, says Macworld? Well, not that long ago, iOS apps running in the background were essentially stuck in suspended animation, unable to do anything until you relaunched them. All of that changed in October 2013, thanks to Background App Refresh, a feature introduced with iOS 7. So when we say we completely revamped Pinterest to be integrated with iOS 7, what that means is we used their background fetch feature to get people's home feeds ready for them before they open the app. Now, this is a really good idea. So instead of opening your phone and seeing a blank screen, you open your phone and there's already lots of inspired pics for you that you can see right away. And so we started to say, well, this change in calculating iPhone DAUs is probably inaccurate, because we know we're doing a background fetch, but we also were featured in the App Store. There was some real effect. How much of this is real? How much of this is due to a change in our logic? So we talked to the iOS developer, and he said, only this one handler is being called in the background. The only thing we do is fetch people's home feeds. And so great. We went back to the data, and someone did an analysis and said, preliminary analysis shows background checks only contribute a small fraction of the DAU gain. Great. Really? That jump is really big. If you're a data person, and I know I said everyone's a data person, so you should all be data people, you're looking at that, and you want to be 100% sure that that growth is real. Because if that is real, you should be trying to get in the App Store every week. This thing is the biggest growth vector you've ever found. And so a few weeks later, we said, you know, it continues to gnaw at me. I really want to make sure 100% this explanation we've found only accounts for a small amount of the growth. And so what did we do? We took that request log that we talked about. For every single request, for every user, we know when it happened, what it was a request for, et cetera. And we can make a graph. This graph is very small, and that's intentional. You're not supposed to see all the details. But the big dashed line is when we launched our new iOS app. And hopefully you can see that to the right of the line, there's a whole bunch of blue and green streaks. To the left of the line, you mostly see little red dots. Blue and green streaks, little red dots. What's happened here is we annotated each of the handlers it was called. So v3 home feed, v3 get pin, v3 get user, v3 get notifications. Hundreds of these handlers, each for different API endpoints. And we just colored them until there weren't any streaks anymore that were red. Just using data to try to figure out what's going on. This is what the analyst said. You can easily see long smears of blue, which are background hits to mostly v3 home feed. These we knew about already, and we did. The developer mentioned that there might be these. But after the 3.0 app is launched, you can also see long smears of green triangles. And there are no corresponding smears of green circles before October 18th. This makes me believe that when in the background, the app can do more than just fetch v3 home feed. Data as software. Software engineer says it can't do this. We look at the data. It sure doesn't seem that way. Something else is going on. Software engineer takes another look. As per our discussions yesterday, I actually confirmed iOS applications can be launched to do a background fetch even when they're not visibly running and not appearing in the multitask tray. This could explain the green streaks we're seeing. So we took an explanation of software. We looked at the data, tried to figure out what was going on. It only accounted for a small amount of the difference. We looked again. It informed how we're understanding our software. Data as software, building this loop. Now that we know that, we can build estimates of different DAU counts when we exclude different handlers. So if we just exclude the home feed one, it's the red line, and if we exclude those green ones as well, and so on. And so we can get a sense of what our actual growth is, depending on which handlers we think are fake. But more than that, we can try to build that into our software. And so instead of having a request log that looks like this, we add another column. And if the request is being called in the background, it says so. If the request is being called in the foreground, it says so. And now we can count these people as DAU because they had an active request, and exclude these people from DAU because they had a background request. Again, it all sounds simple. Everything I'm talking about, you're like, well, of course you should do that. And yet actually doing it is difficult. And actually knowing you should do it is not always obvious either. And so we just adjust our data job. We say, OK, app state is not background inactive. We don't want to accidentally not count as DAU anyone on old versions of our mobile client, so also app state is null. Now we have a new count of who's a daily active user on our platform. And we can see now our revised count goes down a lot. A lot of that jump was not real. In practice, we could have backfilled this data. We didn't. It's complicated. Anyway, I can talk about that as well if you like. But we now have a real count of how many users are visiting Pinterest again, and we can see that we learned about what our software was doing by looking at the data. Data as software. We actually learned something about how our app worked that we hadn't understood before from looking at the data. We understand how activity changed at certain points of time, and we can now add explicit logging that helps us understand what's going on. Counting was even harder than we thought, but now we have a sense of who's coming to Pinterest. Part 3, avoiding data chaos. So we talked about how the app and the API now write through Kafka, the raw request log and the raw API request log. So we have a log of every HTTP request coming in. It's going great. In addition to that, of course, now that we have this capability, we say, well, let's write down some more stuff. Maybe every time someone signs up, we'll say what method they chose to sign up. Was it Facebook or Twitter? What IP were they coming from at sign up? What other information did they give us, and so on. For every event that happens, for every pin, did they do it via the bookmarklet? Did they do it via the button? Where is it coming from? And so on. And in practice, there's more and more and more of these logs. This is a really, really good thing because it means that the developers care about the data. It means they want to know, hey, I'm building this thing. If I log something, I'll be able to find out more about it. But it also means that you have all these topics piling up, and you need to sort them out. The same thing's happening underneath. So we're writing all these logs, and all these logs go to S3. And we talked about how important it was to have derived tables to be able to count things like daily actives and monthly actives. And from the monthly actives and creating the possible spammers into spam-adjusted and spam-adjusted monthly actives and so on. This whole story makes sense. And this story makes sense too. And this story makes sense as well. But soon it turns into this. We have, I don't even know how many tables. I hate to think, probably thousands, tens of thousands, lying around in S3. We don't know what's in half of them. We don't know who put them there. We don't even know which ones are business critical all the time. And so if you're not careful, you soon land in data chaos. The other thing someone else actually talked on earlier today is JSON. So go back to the start of my story. Pinterest is about 50 people. The service is down a lot of the time. We are really just trying to get by and also build in some logging to have a clue what's going on. And so we picked JSON. JSON is really nice because you can read it. Look, there's all some stuff about this pin. You can add stuff to it later when you realize you forgot an important key. You just add it in. But it has some downsides as well. So if some field in it is no longer useful, if it's been deprecated, you don't really get to deprecate it. It just kind of sticks around and doesn't do anything for you. If you add a new Boolean key later, its value will be null on the things that you haven't touched in a while because it wasn't ever populated if you're doing sort of lazy updates, and it won't be backfilled. And so the meaning of null is falsy for some things and truthy for others. And parsing it is very slow. So yes, we have this getJSON function, and you can get fields out of the JSON, but it takes a long time. And so in practice, you created some derived table that you're going to reuse every time. But every time you then add a new key, you're taking away the advantage of JSON, which is you now have to update the schema of your derived table and write a new query. So instead of JSON, we started moving toward thrift. Thrift is just enums and structs. And so we have a struct for a pin promotion that has all these different fields that are integers. That's lovely, they're integers and strings. That could just as well be JSON more or less, except it's serialized differently and so on. But the magic of thrift is that you can actually nest these things. So you can have a pin promotion action event that has a pin promotion inside of it that has nested information. And so you have this very well-typed, well-defined data structure that you can mine as deep as you want to find the connections you need, and none of this data chaos of things floating around randomly. So I just described JSON as untyped and thrift as strongly typed. If you're a software engineer, maybe that sounds familiar. Data as software. Maybe the things that we need to do to keep our software in check are the same things we need for data. So the problems we talked about: proliferation of tables, no clear data ownership, duplicated work streams, lack of schema. How can we turn that into order? Things like a central data repository, key shared tables across the whole company, deprecation of unused tables, tests for data accuracy, self-documenting tables. Well, if I cross out the word data and tables in all of these, and instead stick in the word code and software, this sounds like exactly what we've been doing in software engineering forever. We have a central code repository. You check things into it. We have key shared functions across the whole company. I'm not going to re-implement sorting any more than you are. We deprecate unused code. We have tests for accuracy of our code. We have self-documenting code. And so to avoid data chaos, the solution is the same as to avoid software chaos. Data as software, software as data. OK, I'm going to pause for a second here. What have we talked about so far? We added Kafka logging. Now we have a log of all the requests coming in. We have a clue what's going on. We cloned our databases so that we could do analysis offline of the pins and the users that we're serving at real time, but without adding extra QPS to those databases that will bring our service down. We built workflows to aggregate those data into derived tables we defined. We dropped out requests that weren't important, like email tracking, so we can tell who our actual users are. We squashed spammers. We learned a lot about how our app actually works. We got to ignore some phantom requests that were happening when nobody was actually there. We created schemas for our data, added tests for data accuracy. Where did that get us? Back where we wanted to be at the start. Just being able to count our users and have a clue what's going on. So where do we go from here? Well, we want to count at internet scale. Remember, the goal was to know how we're doing. If you go back to this problem, we saw this big jump in usage and said, well, it's probably because we were featured in the App Store. That explanation is perfectly reasonable, but where does it fall on the spectrum of certainty? So if you're on a range from correlation to causation, a lot of the things you say are much closer to the correlation end than you think they are. The goal of a lot of the data things we do is to move closer to causal inference, move further to the right on the spectrum. An excellent way to do that, here's an example. Per capita cheese consumption correlates very strongly with the number of people who become tangled in their by being tangled in their bed sheets each year. I can make a story for that. If you eat a lot of cheese, then you get indigestion, and then you don't sleep that well, you're tossing and turning in bed, you get tangled in your bed sheets, and you die. That story is not entirely unreasonable. This story also not entirely unreasonable. Maybe it is very, very likely that being featured in the App Store will lead to a growth in our users. But how much? Is my lovely story correlation or causation? And so here, you come to A/B testing, which I would argue is the best way to scale this sort of data and software with your company to know what's actually going on. So quick refresher, you take the population, you divide it into control and treatment, you apply your treatment to the treatment, you don't apply your treatment to the control, you measure what happens. So here you have control enabled, you divide them in two, you measure your outcome. You want people to turn blue. Look, more people turn blue in the enabled group, we should ship it. But should we? A lot of things come in here. I've given a lot of talks on A/B testing. I'm not going to talk about it a lot today. I'm happy to chat about it after. Some simple things you want to know. Was that difference statistically significant? A lot of people say the thing on the left. That's mumbo jumbo. You're talking about whether it's significant or not. It's up. Of course it's up. Like, that is the definition of up, is that there are more of these people. Well, the problem is, if it's not significant, it might not be real. It might just be due to chance. What about novelty effects? It's actually true that a lot of people just click a button because they don't know what it'll do. But the goal of your company is not to add new buttons every day so that people will click them because they don't know what they'll do. It's to create long-term change where people understand the value of these new features. User segmentation. It might affect some people more than others. Pitfall of this is you can go down a very long road of segmentation where you're like, oh no, it looks terrible for men in Kazakhstan. Turns out there's 8 of them. You probably don't care. You have to be careful with this. And lastly, randomization errors. The enabled group is so much higher. Well, it turns out that you randomized people incorrectly, and so the enabled group was better before the test began. As I said, I'm not going to go too much into this. But again, in the data as software theme, this is where software can really, really help. Doing the right thing should be easy. Doing the wrong thing should be hard. Build tools that make it easy to do the right thing with data and hard to do the wrong thing. Only show significant effects. Differentiate novelty versus long-term effects. Let your tool allow people to compare important user segments without clicking on a million dropdowns. Show them when there's randomization errors, and so much more. Counting at internet scale, please do A/B testing. This was a very short segment of a longer talk, but I'm happy to chat about more. Data as software, where are we now? Leverage A/B testing, scale insights with tools. Doing the right thing should be easy. Doing the wrong thing should be hard. Theme of the whole talk, counting is hard. We got everything wrong at every step of the way. First, we didn't have any logging at all. No clue what's going on. Then we logged every request as a DAU. Well, we shouldn't be. Certain things don't count. Then we had spam interfering with metrics. It took a long time to parse our logs. We had background fetches. I didn't even talk about things like browser tabs that people leave open, screensavers that are running, widgets that people install on their websites, all sorts of things where to do the data correctly, you have to know how the software works. You have to think about, well, gee, if you put a widget on the web page, should that count as a DAU or not? What does that look like in our logs? And all sorts of things I didn't talk about. What app are people in? What country are they in? Those questions are harder than you would think. Data is unruly. If you don't have data governance, you're going to end up with chaos. The solutions are similar to those for software. Use thrift, use strongly typed things, write tests. And lastly, for scale decisions, do A/B testing, automate metrics collection, make it easy to do the make it easy to do the right thing and hard to do the wrong thing, and build a culture of experimentation. Data as software, software as data. You can't be good at data without understanding the software. Your software will not be as good unless you have data. Thank you. And I should have time for questions.
Yeah, there's at least one question through the app. How have you solved the problem for legitimate users from Asia that were posting many pins, but that weren't relevant from the user for in Europe?
Sorry, how do I prevent?
The problem you showed with the users from Asia, how it's solved, or how did you block them probably?
Yeah, so.
And it's not relevant to a user from Europe who is posting things like that.
OK, so the question is, how do we prevent sort of spam from Asia from affecting people in Europe? We actually want to prevent spam from everywhere from affecting users anywhere. That's more in our real-time systems, but it's actually fairly similar in that we try to use the data to detect mass action and prevent people who are taking mass action from having effects on people. That's very general, if people have more specific follow-ups, I'm happy to follow up offline. But basically, you can detect these things with things like machine learning or just handwritten rules. And then the main goal is both to get correct business metrics, which is what I talked about, and also to make sure the experience of Pinterest is positive for our users, which means preventing those people from disseminating their content.
Any other questions?
I remind you of the free Pinterest membership available to all. Thank you for coming.
Thank you for your talk.